Good day, I am Angela Lim, ID 122, and I will be teaching Foundation Math, Long List number 2. The topics include domain and range, exponential and logarithmic functions, and matrices.
For the first problem, we'll be solving an equation that involves domain and range of a function. So our equation is y is equal to 1 over x squared of x squared minus 1. So in finding the domain, what we need to do is to find the x values that would make this equation undefined. Para malaman natin all of the x values that will be the solution for this equation. So in finding the domain of a function, what we usually do for a rational function is to equate the denominator with x values. Equate the denominator to 0. So the whole thing is equal to 0. And then for root functions, what we do is, since for a root function, when your value inside the root is equal to a negative 1, it makes it untrue, or it doesn't become like a real value. So what we usually do is to equate the 1 inside the equation here to greater than or equal to 0. Para all that we get are the positive values only that we can find the root of. This is true for like a square root, since it's an even root. So to find the domain of this function, we have to do these two standards to find what values of x would make this function undefined. So to start off, we can just equate this whole equation to 0 for the first rule, which is anything that has 0 in its denominator is undefined. So at x is equal to 0, your function is undefined, and also at x squared minus 1. But since this is a root function, we have to find x squared minus 1 is greater than or equal to 0. That's also x squared is greater than or equal to 1. And it will be greater than or equal to positive or negative 1. And since it's an inequality, we have to find the values that is part of the solution. So we have x values that are less than negative 1, values between negative 1 and 0, between 0 and 1, and greater than 1. So we need to just find test values for this one for x squared minus 1, or like the value inside the root. So we can test negative 2 here, negative 0.5, 0.5, and positive 2. So we need to only monitor the signs, kasi just a simple positive sign would tell us that the value of x satisfies the solution, which it has to be greater than or equal to 0. So negative 2 squared would be 4 minus 1, so that's a positive. This one when squared will give a value lesser than 1, so it's going to be negative as well as this one, while 2 will also give us a positive value. So this tells us that what's part of the solution is only this one and this one. So this is your domain na. For domain, you can write it in an intervalation, which is negative infinity up to -1. But this is on a parenthesis because for -1, this is the value that would make the denominator 0 na. We said nga na denominators cannot be. So the value of -1 is not part of the solution. Yeah, we're going to just write it in a parenthesis. And then also 1 up to positive infinity. For the range of the function, these are the y values of the function. So if these are all our these are all our x values, we just need to plug it in the equation to know kung ano ba yung range or ano kaya yung possible y values that we can have. So for negative infinity, when you plug this in here, you're going to get still negative infinity. -1 will give you a value of 0, but since we're not allowed to have a 0, 1 in the denominator, we're just going to write it here, but it's still not part of the solution. And same goes for this one. And positive infinity. So here is our final answer for this problem. In this problem, we are asked to use the matrix inverse method given a coefficient matrix and a constant matrix to find the unknown matrix C. So matrix inverse has the equation or the formula A is equal to XC. A being the coefficient matrix, X the unknown matrix, and C the constant matrix. So to find the value of C, we're going to take the inverse of A, multiply by the coefficient matrix. And we know that an identity of the inverse matrix is the adjoint matrix over the determinant of the matrix. And also, we can further simplify this adjoint matrix into just being the transpose of the cofactor matrix. So finally, what we have to do, or like the step-by-step process of solving this problem, is to get the cofactor matrix of A, transpose it, and divide it by the determinant A. Okay, so if this is clear, we're going to start with getting the cofactor of the matrix A here. Also, we have to multiply this by C, which is your constant matrix. In this case, it's matrix B here. Okay, so to find the cofactor of matrix A, we can use the deleting of rows. So, okay, let's erase the annotations here. For A, C, we can start with A11 or the first row, first column. So what's left is this one after you deleted the first row and the first column. So that's 1, -1, 2, -2, -2. And then the sign would be positive. And then next we have A21, which is row 2, column 1. And the sign for this one is negative because we have this positive, negative, positive, negative, positive, negative, positive, negative, positive. So the sign for this one is negative. We have 1, 1, negative 1, negative 2, negative 2. Then we can delete this and then proceed to A31, which is row 3, column 1. That's positive. So 1, negative 1, 1, negative 1. And then now we can erase this one. And then let's just retain yung formula that we will use, which is this one. Maybe we can place it here na lang. Okay. So next we have A12, which is row 1, column 2. That's negative. So 1, negative 1, negative 1, negative 2. And positive here. Delete this row, delete this column. We get 2, negative 1, negative 1, and negative 2. And then row 3, column 2, negative 2, negative 1, 1, negative 1. And then we proceed with row 1, column 3. So we're left with positive sign 1, 1, negative 1, negative 2. And then negative 2, 1, negative 1, negative 2. And then plus 2, 1, 1, 1. Okay, so finally, to finalize our cofactor matrix, we will be diagonally multiplying this one minus this one. So positive 1 times negative 2 is negative 2 minus positive 2. That would give us negative 4 minus negative 2 minus positive 1. That's negative 3 times the negative sign here. So that's going to give us positive 3 plus negative 2 plus 1. That's negative 1. Since we have a positive sign, it's still negative 1. Negative 2 minus positive 2, that's negative 4 times the negative sign here. So we have positive 4. And then negative 4 minus positive 1, that's negative 5 times the positive sign. We have positive 5. Negative 5. And then negative 4 plus 1, that's negative 3 times the positive sign, negative sign. That's positive 3. negative 1 minus negative 1, that's 0. So, negative 2 plus 1, negative 1 times the negative sign, we have 1. And finally, 2 minus 1 is 1 times the positive sign, so that's 1. This now is your cofactor matrix. And then we take the transpose of this matrix to get the adjoint matrix, and that's going to be just transforming the rows into columns. So negative 4, 3, negative 1, 4, negative 5, 3, and 0, 1, 1. Okay, so this one is your adjoint matrix.
Thank you so much for watching. You may also avail some past tutorials by scanning the QR code flashed on your screen. Once again, this is Angela Lim from Syntax, paving your way to excellence.